Okay, so in the previous tutorial we have implemented this NPC AI character, and now that NPC can move to some random locations in the level. Plus you can see some debugging sphere has been drawn on the level as well, so this would be easy for us at the development when we need to actually debug our NPC AIs. Right, now what I'm going to do next is basically currently NPC is only jogging towards that specific random location, but instead I just want to control its movement mode. For example, like if I need to make this NPC AI to walk for a specific random location or a specific location, then I need to be able to do that. Or let's say I just want to make this character crouch or maybe sprint, so I should be able to do that specific transition. Right, so now let's see how we can do that. Okay, so first what I'm going to do is going to my characters NPC AI folder and open up my behavior tree. So we have created our own custom blueprint tasks, behavior tree task. So similarly, I'm going to create another behavior tree task to set a specific movement mode, right? Because if you remember at our character level in the locomotion system, we have this movement type, right? So based on this enumerated value, I can get or I can manipulate whatever the movement type the specific NPC is inherited for. Right? Okay, so that's the logic. So let's create it. So I'm gonna create a new behavior tree task by using this BTT task blueprint base as the parent class. So I'll save a new BTT at task folder known as set movement type. Right. So here I'm going to receive execute AI, and as usual let's promote control pawn to a parameter called maybe pawn, and then I need to get the locomotion system first, right? So I'll get the locomotion system, and only if we have a valid locomotion system has been implemented on the NPC AI, we can do this toggle. Right? Otherwise, actually, this character doesn't know about or doesn't aware of these sort of uh, features, right? So we first need to check whether our control pawn is having a locomotion system that is being implemented as an actor component. So in case if we haven't implemented it, then simply we can return a finish execute by saying it's unsuccessful, right? But let's say if we have a locomotion system, then I can set the movement type by using this function, and I should have a way to manipulate this parameter. So I can promote it into a variable called movement type and make sure to mark it as public or instant editable. Then it will be available at the behavior tree. Right. So now what I can do is after successfully setting this movement type, I can return a finish execute as a successful invocation. Right. Now let's test this thing. So to do that, I can go to the behavior tree, and maybe before taking a random location, I'll set movement type. Right. So currently it's none, but let's say I just want to make our character walk. So I can select it's at walk, and let's try to play it. Now you can see instead of jogging, the character is walking towards that specific location, right? Which is much more convenient, right? So we have the control over player's movement time. Okay, right. And then what I can do is maybe let's try crouching as well. Plus, I'm going to switch my NPC's rotation mode to strafing just to see whether the turn in place been applied properly. Okay, character is crouching. Yeah, it seems like turn in place doesn't work yet because I can see like sudden rotation to the specific location. You see? Right. So I'll make it as forward facing, and maybe later on actually we can improve the turn in place. But for now it's fine. It's just a small thing. Yeah. Now it can crouch as well. Right. So we have the ability to do that. But I think maybe we can do this before waiting, right? So when the character is starting, it's starting from crouch mode onwards, right? Which looks fine. And one other thing to understand that whenever the behavior tree functions are executing, first it's execute like this. It goes to the root, leftmost root node, and after reaching to that specific node, it execute in left to right fashion, right? Within this specific tree level, right? For in case like if you switch this stuff, you can see there is a node appearing at the right corner. So this one is the first one that is going to be executed, then this one the second one, this one is the third one, and this one is the last one, which is the fourth one, right? But in case if you change the order, you can see the order of execution will be changed as well, right? And so currently I'm just hard coding this specific movement type variable at my behavior tree, but maybe let's say I want to randomize it, right? So whenever this node is executing, or this specific branch is executing, maybe the movement type should be configured randomly, right? Maybe it can be walk, maybe it can be jog, maybe it can be crouch, right? So in order to do that, we can go to this set movement type. Let's add a variable called random, right? And make it as instant readable, so it will be accessed through the behavior tree. And let's say if this one is random, instead of hard coding the movement type like this, we should be able to randomize the movement type. So I'm going to get this one, and let's select like this as the movement type. So let's say the movement randomization is false, then I'm just going to consider whatever the movement type it has at here. But let's say if this one is true, then we should be able to randomize. So now do that. Maybe I can yeah, I can maybe make an array or maybe I can create a list, maybe movement type list, which is the type of movement type, and should be a array. And I'll use this one like this, and as the valid variable values as the movement type is, I'll select walk, jog, and crouch. Right, and this one should be initialized only once. So let's see what are the events that we have. We have, do we have an initialization event? Yeah, I think then let's initialize this list at here, something like this. And then if it is random, we are going to select a random array element from this array, plug it to here. Okay. Right, now if I go to my behavior tree, and let's say the set movement types randomization is true, and if I play it now, you can see at the first we have walk, and then we have jog, and then it seems we have crouch. Right, so the movement type is randomized. Right, I can't exactly decide what's going to be the next movement type, but anyway it's going to be a random movement type. Okay, so we are almost there, but I think another feature I can add this specific behavior tree task is distance based movement type. Right, for example, let's say if this NPC is trying to reach to this position, right, and let's say this one is since closer to this specific NPC, maybe the character is walking towards that specific location. And let's say if the character is on a distant location, so since this target is a distance, then the character is jogging towards that specific target location. Right? So this is another feature that we can use to have much more realistic NPCs on the level. So I'm going to add that to here as well. Right, so what we can do is first we need to determine what's the target location that this NPC is going to be moved, right? Like in this behavior tree, at the move to location we added this blackboard key called move to location to get that specific target location from the blackboard. So similarly I think we can do something like that. So go to the set movement type PTT again and create a new variable called move to location, which is a blackboard key selector, and it should be a single variable. And I'll move it to up like this and make it a public variable. And also I'll add another variable called maybe let's say enable distance based movement transition. This should be type of boolean and instant readable. And let's say if this one is enabled, then the move to target location will be considered as the distance to be traveled. The distance based movement will be applied. Right, so do that, I'll make some space here. Let's get this variable, and if this one is true, then I'm going to get this move to location and get the blackboard value as a vector. Also I need to get the pawn's actor location, so get actor location, and let's find out the distance, right? The distance in between two points or two locations, and I'll promote this to a variable called distance. Right, maybe I'll make some space more. So if I captured my distance, and then I need to determine how much of a distance that I should be able to check in order to make a proper movement transition. Therefore I'll create a variable called maybe let's say walk distance threshold, and this should be the type of float, and maybe by default I'll give like, I don't know, maybe like 200, right? And I'll make it as instant readable. So if our distance is within this threshold limit, then the movement type should be walk, else it should be movement type of jog, right? So how we can do that? Yeah, maybe I'll use this one again, and I can get the distance is less than or equal to this walk distance threshold. If it is, then I can select the movement type. Right, instead of manipulating this one, maybe I'll create another variable called L underscore movement type, which is the type of movement type. So this L is basically stand for local, but in this scenario actually we can't explicitly determine what's our movement type as local variable, because this one is just an event. Only if we use the functions that we can do that thing. Yeah, maybe, yeah, this would be fine. So I'll set it here like this, and if the distance is within this walk distance threshold, then it should be the type of walk, otherwise it should be jog, right? Okay, then instead of plugging here like this, I'll remove this pin and I'll add a sequence here. And so first I will execute this path, and if our enable distance based movement transition is enabled, then it will set a movement type accordingly. Or we can do this part at here as well. Or if I enable randomization, then I'm going to select a random array element from this movement type list by using by setting this L movement type, right? So I can get rid of this one, and then I'll remove this pin as well. And I can remove this stuff, and instead I can plug this one, L movement type, right? Then as the third execution pin, I'll simply check this logic whether we have a locomotion system is been implemented or not. So if we have been implemented, then we can set it something like this, right? And I think we can do further optimization, which means we are only using this list whenever we are considering a randomized movement type. So instead of initializing is at each time, I will cut it from there and add it to here, right? So only if we have a randomized movement type is been enabled, then this list going to be initialized. Okay, right. And let's say somehow we haven't add any of these stuff, then by default the L movement type should be whatever the movement type that we've been provided, right? Therefore I'll set it at here, right? So this is the default movement type, and these are like sort of overridable states, right? So I'll comment this one as let's say distance based movement type, and this one is randomized movement type, and this one is like setting the target movement type. And I'll add a bubble here called default movement type. Okay, Now I'll go to the behavior tree, and as the set movement type, now I can check enable distance based movement, plus make sure to set the movement to move to location as target location, and the walk distance threshold is 200. Plus first actually we need to fetch this target location to calculate the distance properly. Otherwise this target location will be the old target location if we keep it as like this. So I think first we need to get the random location, then we can set the movement type, then we can move to location, right? And wait can be done at the very first. Okay. Right, so let's check. Okay, you can see now the character is sort of crouching because I think I have enabled this randomization. That's why actually it is randomized. So I'll disable this random variable. So let's check it. Now you can see the character is jogging to that specific target location, and for the closer location he is going to walk, and again for the distance location he is going to jog, something like this. If it is a closer point, he's probably going to walk, right? Maybe I'll increase this distance a little bit just for testing. Otherwise most of the time we are getting a distance location. Now you can see, like, since this is a closer point, he's going to walk, again he's going to walk, something like that. And that's also a closer point because I set the work location as 1000. Maybe how about 500? Okay, walking. Okay, jogging. It works properly. Right, now let's say if I enabled crouch, movement type as crouch, so this guy should crouch. Okay, because it's, I just disabled the distance based movement. Let's say if I enable the random, let's play. Okay, now it's a random behavior, so I can't actually decide what could be the next movement type. Right, it works properly as well. Okay, so I think those are the features that I want to cover about setting the movement type. So if I brief what we have been done, basically first we created a way to actually manipulate our movement type of our targeted NPC character, and then we added a randomization where we can actually randomize the movement type, and at last we added the distance based movement variations or movement transitions, so that, like, based on the specific targeted threshold, it can decide which sort of a movement type it is going to be done, right? So it can be either a walk or jog based on this specific threshold that I configured here. And all of this stuff can be configured at our behavior tree level, right? So you don't need to go to tasks again and do the code modifications, right? So that's it, and I'll see you in the next one. Thank you.